This is the second unit, last topic before, okay, fifth topic. So only one topic is available to complete our second unit. So last class we have seen descriptive analysis. So this is a recall. Descriptive means is a expanded of the way. So we have received the data from example hospital management. Okay. After that, you can receive the data and split your data and compile, and after verify your data and visualize your data after taking your decision making. This is a way to descriptive analysis. Descriptive example, you take a hospital management now, you can take your name, address, phone number for particular inpatient or outpatient data. This is the analysis of particular department. For example, another example for a department of urology, department of nephrology. So depends on department, you can visualize how many patients can be incoming per month and outgoing per month, and what are the taking decisions. Okay, this is the last step of saying your descriptive analysis. Next we go for same descriptive analysis, and next result score. Synergy data analytics concept based on your standardized relationship, correlation, visualize correlation, and scatter plots, and visualize standardization and result score. So this is the most important thing in your result score. Okay. So first you have received the data standard relationship. What is the relationship between data analyst and your value? Okay. For example, the student information. Okay. For me, what? Okay, this is a statement. Okay, above your student faculty to analyze your mark statement. For example, student mark statement. For example, and microprocessor and microcontroller and discrete mathematics based on what is the score, how many of you passed, how many of you failed, and what is the maximum mark, what is the minimum mark. So we visualize easily taking decision about the number. So this is the standard of relationship. Second thing, correlation. So between mean, mode, median, figure, that means condition analyze your how many of you maximum, how many minimum. What is the median value of your class? Example, class average. Okay. For example, class average now, how many of you clear? Yes or no? Yes or no? How many of clear? So last semester, how many of clear means you have 34 members now, 31 members clear, and 3 members are fail now. Particularly only one subject now, that is the average, class average. So divide 31 divided by 34 into 100. That is the average of the class. This is the correlations. Sometimes based on modified. The other than you can take a decision. Okay. Next one, visualize correlation. Visualize means giving the plots or bar chart or line charts. Easily taking a decision about the particular data. Okay. Next one, your scatter plot, dotted. So you can find out value based on which one is the maximum, which one is the minimum. Next one, visualize standardization. Each and every sector to follow a standard visualization process. Finally, result score. So result score is also known standard score to indicate how many standard deviation in element in from the mean. Mean maximum, mean based on that we can find out. So how many numbers clear? Okay, how many numbers clear for your subject now to find your mean value. Okay. After that, the exact score can be calculated for any normally distributed data sets. For example, 0 or 1. So maximum draw 0. Okay. So this is a condition for particular area. And second thing, the power of result score data is standard outlier reduction and cross distribution comparison and standard probability and outlier probability and probability calculation, outlier identifications. This is maximum based on your result score. Okay. For example, there is no problem. 0 or 1. That's all. Result score. This is one of the formula for result score. Result score is calculated using following formula: z equal to x minus of mu divided by sigma. So where z is the score, x is the observed value. So you have 10 values are received. Okay, 10 values are received. Now you can take mu population of means. What is the mean value? Okay. Second, if you have a sample instead of entire population, you would use the sample mean x. The sample standard deviation equal to x minus x bar divided by s. For example, problem, suppose we have data set test score mean 75 and standard deviation of 10. The standard score 85. The test, what is the standard z score? Given z, we have two values are received. One 75, another one 85. 85 minus of 75 divided by 10. Divided by 10, standard deviation is given value. Suppose the value is not given, now you can assumption you take the value. Okay, the particular value 75 is giving and 85 is giving, but this standard is 10. But value is not giving. Now you can take, that means you can assumption. Suppose you can take 9 or 8 or maximum 11, 12. You can assumption equal to 1. So that means standard score is 1, standard deviation above the mean. Suppose more than one value of now is not standard. And what is the condition? 0 or 1 condition. Okay? You can attain your value. Okay? You attain your value. Then assumption is based on the particular sector. So this is the understanding correlation, standard deviation. We have positive correlation and negative correlation. The positive correlation based on variable increasing together and coefficient plus 1. But we have variable decreasing together and coefficient of minus 1. So one example, if you receive a mark, okay, if you receive a mark 25, okay, no problem. If suppose you can show the verify marks less than 1, whatever. Whatever. Sir, I need more marks, sir. So please verify, sir. Whatever. The particular faculty can be verified. If you put an increase mark ratio positive, suppose the value can be reduced now to negative. So this type of process are done by the sectors. Maximum. So this is one of the person correlation coefficient. This is a formula R equal to sigma x of I minus of x bar, y of I minus of y bar, and divided by sigma sigma x of I minus of x bar whole square and sigma y of I minus whole square y bar of whole square. Okay, so you can, where R is the percent correlation coefficients. For example, 10, 20, 30, 40, 50. And xi and yi is our individual data point. Individual data point myself. Okay? Yes. One, okay, x2 and n number of x of n. Okay, what? X of n 10, 20, 30, 40 and 100. N number of values. Okay? So n number of values. X of I, y of I, individual data point. That means myself here and there. Okay. After that, x bar, y bar, the sample means overall value. So 10 numbers is na. 10 numbers you can calculate divided by 10 put na, that is your mean value. Okay. So next one, sigma denoted summation. Interpretation of correlation is 10. After y, extract interpretation can depend on context. This is the here. R greater than 0.7 strong correlation. Greater than 7 and okay? In a correlation, strong correlation. In 0.52, less than or less than 0.7, moderate of correlation. After that 0.2 less than of or less than of equal 0.5 weak correlation. So this R greater than equal less than equal of 0.3 very weak or no correlation. This is the way to analyze your value. One side, this is the value, okay, and divided final value and check your condition based on models of power. Greater than value of Igana, there is strong correlation. 0.7 more than value of the okay. Suppose less than the particular point between is not moderate correlation. After that, other than less than 0.5 kilo, there is a weak correlation. Less than that is very weak. Okay. This is activity, correlation genus, time 10 minutes, mode, whole class, state, height and weight, study hours or marks, shoe size and intelligence. For example, height and weight. What is my height? What is my weight? You can analyze based on your class. Second thing, study hours and marks. You can improve your study hours, you can get a good mark. If you are less than your study hours, you can. This is the condition. And shoe size and intelligence based on your thinking. And student predict positive correlation, negative correlation, no correlation. This is a way of identifying. Suppose my height, example, my height is 160 now, my weight is 16. This is a positive. More than this now, this is negative. Otherwise, under the value of this now, there is no correlation. Okay, what? So, interpretation of percent correlation coefficient based on between strong or 0.6 and moderate 0.6, 0.4 weak and very weak 0.2. Okay. So, how to use scatter plot and data analytics based on visualize relationship and identify relationship type and identify outlier and access of the correlation state. Once you have received the data and plot your value. For example, x-axis or y-axis. Okay, define now. For example, x-axis is the height dimension, y-axis is the weight dimension. Sometimes weight is height dimension. You can mention your value. This is the way to represent your scatter plots. We will take x-axis. So first put x and y. Okay. Serial number 1, 2, 3, 4, 5. Serial number 1, 2, 3. Here 20, 30, 40, 50, 60. Okay. So this data can be received from example. X is a MPMC, Y is a data science fundamental mark. For example, okay. So this is the mark from faculty members. Imagine that. You can imagine that. For example, I have convertible isolation. Sorry. I choose a chart. Draw. First. So here. So I choose charts. So 1, 2, 3, 4. After each and every management or your institution peoples to take a decision based on the marks. Okay. The student number 1, 2, 3, 4, 5. The first subject, second subject, first subject, second person, second subject, second person, third person first subject, and third second subject, fourth person first and second subject, and fifth person first and second subject. Which one is the minimum? First one is a first subject. First subject is the minimum. Why? Is a 10 marks. So you can take a decision what happened. The member can ask questions what happened. Even though your industry, in public department or manufacturing industry, you can show your quantity produced selling a product. I'm sure this visualization is required easily taking your decision. What happened? You ask them feedback from your stakeholder or customer. You can ask them, and then you can take a decision and improve what is the conditions. This is a way to represent easily in your area. So this is a scatter plot creation, a scatter plot interpretation. Scatter plot creation means choose a two variables. Now I have two variables. I can show you two variables: x value and y value. Third one, label. Which one is it? Label person 1, person 2. Okay. X axis is a person 1. Y axis is a mark. Yes or no? X axis is a person 1, 2, 3, 4. And y axis is a mass statement. And plot each data. So I am using scatter plot now. This type of process. Suppose I am choosing bar chart, you can easily find out. Say, if you have scatter plot interpretation, first identify correlation type, second recognize non-linear pattern, third deduction random scatters in your area. So last one, mind map. So what are things already talked about? Just your mind map. Mind map is you can based on your friend's sort of first name or food sort of first name. Or if anyone easily understand what I talk. Okay, so first thing Z score correlation scatter. So Z score for the you can choose first formula and positive Z score and negative Z score. And interpretation of positive relative means and activity calculate your Z score value and compare your Z score value. Activity calculate Z score, compare your Z score, combine activity and compute Z score value, and for next one you can draw the plot, draw the scatter plot and combine activity, compute the Z score and draw the scatter plot. Difference we have x value or y value is available now. You can combine one and visualize your if any one of the plots. So correlation positive negative, no correlation. We have using that value. So you can choose value. Minus R2, that's the you have available value, and scatter plot, visual relationship, and scatter points and trend lines. So value of raw value, be positive question of value of related to the mean and total frequency and variance. If any one of you tell the answer.
If it's called representation, the answer is the question of the value related to the mean.
Well, answer is B and question of the value related to mean. So you can receive the value now. Overall value divide by n number of value and divide by that is the mean value. Second, the formula for Z score is if any one of you. Formula for Z score.
Answer B, x minus mu divided by sigma.
Okay, for example, x value is the number of value, mu can particular process, overall divided on number of value. So value is that you can take a value now, you can easily find out the result score. For example, 0 or 1. Suppose you can find out 0.7 or 0.7 to 0.5, 0.5 to 0.3, 0.3 less than a big process. Okay, thank you. Reference books and thank you.